Now let's implement abstraction in C#, using a car example. First, we'll import the system namespace. Then we'll create a namespace for our project.
Now let's create our abstract class. An abstract class acts as a blueprint for all car types. We'll name it car. Inside the abstract class, we'll declare an abstract method. Notice there's no method body here. Each child class will provide its own implementation. Our abstract class is ready. Now let's create a sports car class that inherits from car.
Since car contains an abstract method, sports car must override it. Now we'll define how a sports car starts its engine. Next, we'll create another type of car.
Now let's create another child class called electric car. It also inherits from the abstract car class, but its engine starts differently.
Every child class must provide its own implementation. So we'll override the start engine method. Notice how the behavior is different. Let's create one more child class. This time, we'll build a luxury car. It also follows the same blueprint.
Luxury car also overrides the abstract method. Each class decides its own engine behavior. This is the flexibility abstraction provides. Now let's test our abstract classes. We'll create the program class and the main method. In the next part, we'll create our first object. Now notice that we're using the abstract class as the reference type, but the actual object is sports car. This is one of the biggest advantages of abstraction. Now let's call the start engine method. Even though the reference is car, the sports car implementation will execute. Let's verify it. Now let's replace the sports car with an electric car. Notice that only the object changes. The rest of the code stays exactly the same. Let's test one more implementation. We'll create a luxury car object. Again, only the object changes. Our coding is complete. Now each object will execute its own implementation. Let's run the program and see the output. Let's run the program. The first output comes from the sports car object. Even though the reference type is car, the overridden method in sports car is executed. Now the electric car object calls the same start engine method, but because it has its own implementation, the output changes automatically. The method call stays the same, only the object changes. The luxury car object also uses the same method call. Its own implementation runs automatically. This is the power of abstraction combined with method overriding. One abstract class can support multiple child classes. Each child provides its own implementation while using the same method name. That's what makes your code flexible and easy to maintain. You've successfully learned abstraction by building a complete C# example. Practice this code yourself and try creating another child class. In the next lesson, we'll continue with another important concept.